All right, let's continue. Logarithm 2 base 50 plus 1 over 2 logarithm 2 base 16 minus 2 logarithm 2 base 5. In this question here, we cannot go further. Why is that? Because logarithm say that 125 is equal to x. What is the base here? 10. 10 to the power of x, we write as index 1, 125. 125 is 5 cubed. So there is no, bases are not same. We can't say that x is equal to 3. What we can say that logarithm 125, we calculate what is logarithm 125 by the calculator. So logarithm 125 by the calculator, that makes 2.1. So the result is 2.1. Okay, here, what am I going to do? All the logarithms are base 2. I can contract them, but we have coefficients here, so I have to get rid of those coefficients first. Then logarithm 2 base 50 plus logarithm 2 base 16, that comes as power 1 over 2, minus logarithm 2 base 5 square. That comes as the power. Then, what is 16 to the power of 1 over 2? Let's find it out. What is 16 to the power of 1 over 2? 16 is 2 to the power of 4 to the power of 1 over 2. That makes 2 to the power of 4 times 1 over 2. Multiply the powers. That makes simplified square. 2 square is 4. So that's equal to, the whole thing is here equal to 4. So how do I contract these two? Same base, an addition, logarithm 50 times 4 minus logarithm 2 base 2 of course here, 5 square is 25. So that makes logarithm 2 base 200 minus logarithm 2 base 25. Same base, there is subtraction in between, logarithm 2 base, it's going to be 200 divided by 25. That is logarithm 2 base 8. If it is x here, 2 to the power of x will be equal to 8. That is 2 cubed. Then x will be equal to 3. So when we evaluate this, the whole function is equal to 3. Yes. Let's move on to the next slide. We continue to evaluate. Let's look at here, number E. Logarithm 3 base 1 over root 3 is what is the result of this? So this is equal to, say that x. Let's write it as index form. 3 to the power of x is equal to 1 over root 3. 1 over root 3, can I write root 3 as 3 to the power of 1 over 2? Yes, I can. And how can I write it in the numerator? 3 to the power of negative 1 over 2. When you move the number to the numerator, you change the sign of the power. So same base number, power have to be equal. X is equal to negative 1 over 2. Let's look at this example here. Logarithm 2 base 8 root 2. Okay, I can simplify this, or I can write it in a different way. How we can do that? Okay, let's answer it in a different way. Let's say this is x. We are evaluating. So 2 to the power of x is equal to 8 times root 2. 8 times root 2, 8 is 2 cubed. Root 2 I can write as 2 to the power of 1 over 2. Same base number, when you multiply them, what do? We add the base, we add the powers, 3 plus 1 over 2. That makes 2 to the power of 7 over 2, and x is equal to 7 over 2. I can solve this in another way. There is not only one way. Logarithm 2 base 8 root 2. Now, can I expand it? Yes, I can. Logarithm 2 base 8 plus logarithm 2 base root 2. When there is addition in between, same base, what do? We multiply these two numbers, right? That I reversed the process. Yeah, I expanded it. So Then logarithm 2 base, what is 8? 2 cube plus logarithm 2 base, what is root 2? 2 to the power of 1 over 2. When there is power, power comes in the front. 3 logarithm 2 base of 2 plus power comes in the front. 1 over 2 logarithm 2 base of 2. Logarithm 2 base of 2 is equal to 1. So 3 times 1 is equal to 3. Logarithm 2 base 2 is equal to 1. 1 over 2 times 1 is equal to 1 over 2. So the result is 7 over 2. We got the same answer. So we can solve it in any way we want. The next question is simplify. Not evaluate, but simplify. So you're not going to write a number as an answer, but you will leave it as a function. Logarithm a base 5 plus logarithm a base 8. Same base, there is addition. How do I contract them? Logarithm a base 5 times 8. So that is logarithm a base 40. So that's the answer. Can I go a step further? You can't. 4 logarithm x base 2 plus logarithm x base 3. Can I contract them? Not yet. I have to put this the coefficient as power. Logarithm x base 2 to the power of 4 plus logarithm x base of 3. So logarithm x base to the power of 4 is 16 plus logarithm x base 3. When there is same base and addition in between, logarithm x base 16 times 3. We multiply the numbers. Logarithm x base 48. So that's the answer. Okay, let's look at here. Number C. Logarithm x base 6 minus logarithm x base 6x. So since they are the same base, can I write it as logarithm x base 6 over 6x? Yes, I can. So we simplify 6. What left there? Logarithm x base 1 over x. Right? So what do I do here? Very simple. Logarithm x base 1 over x. Can I write x to the power of negative 1? Yes. Power comes in the front, negative 1, logarithm x base x. What is logarithm x base is? Base and the number are same, 1. Negative 1 times 1, negative 1. Or you can also write it this way. You can evaluate it this way. Come on, we need to erase that. 1 over x. So let's say that this is equal to y. How do I write as index form? X to the power of y is equal to 1 over x. 1 over x is x to the power of negative 1. It means that y is equal to negative 1. Either solve it this way or solve it that way. You will get the same answer. Okay, we gotta stop here, and there will be a second part of the logarithm coming soon.